Okay, lesson 10.7, factoring special products. So, factoring special products, this is just a shortcut for you guys. Okay, if you notice a quadratic falls into one of these patterns, then you don't have to go through factors of A and factors of C to get to B. Okay, you can just write it as one of these special products. Okay, so the first, they are, and you've seen them before in 10.3. So the difference of two squares and perfect square trinomials. Okay, difference of two squares tells us, first of all, you're looking for two terms. Second, is the first term, can the first term be written as a quantity squared? And can the second term be written as a quantity squared? Also, it has to be subtraction. Doesn't work for addition. Okay, if it can be, then it's just the first plus the second times the first minus the second. So when you look here, 4x squared minus 9. 4x squared is just 2x quantity squared, and 9 is just 3 squared. So it's a difference of two squares. Okay, perfect square trinomial, same thing, but what you're looking for is, first of all, three terms. Okay, the plus or minus is fine, but three terms. The first one, can it be squared? The last one, is it something squared? And then is the middle 2 times whatever the first and whatever the last are. If it can be written this way, then it falls into this pattern. Okay, so this is x squared, this is 8 squared, 2 times x times 8 is 16x. So that's how I got it, x plus 8. Okay, and then the minus is just if it's subtraction here. And then it's subtraction there. Okay, so how do these work with numbers? So m squared minus 9, okay? Does this fall into one of our special patterns? Okay, well, I look at it and I say, well, m can just be m to the second power, and then 9 is just 3 squared. Okay, so it's a difference, it's two terms, right? So then what that means is I can factor that to the first plus the second times the first minus the second. So m plus 3 times m minus 3. Okay, something like 49q squared minus 81. Well, if I look, 49 is just 7 squared, and q is q squared. So I get 7q squared minus 81 is just 9 squared. So I was able to write it as something squared minus something squared. So then I can factor that to 7q plus 9 times 7q minus 9. Okay, difference of two squares. Then if I have something like 12 minus 27x squared, I want to think it's a difference of two squares because it's two terms and it's subtraction, but 12 is not something squared, okay? Not a whole number squared. So what I need to do is to see if it falls in. I'm going to see if I can factor out a common term. So if I factor out a negative 3, that means I'm dividing by negative 3. Okay, 12 divided by negative 3 is negative 4, and negative 27x squared divided by negative 3 is positive 9x squared. Okay, then just going to rearrange this so it looks like a difference. So that would be 9x squared minus 4. Well, can this be written as the difference of two squares? So 9x is just 3x squared minus 4 is just 2 squared. So I do have the difference of two squares here, okay? So when it comes to factoring, I still have a negative 3 out in front because that's what I took out. This is the difference of two squares. So I get 3x plus 2 times 3x minus 2. And I factor that. So I took out that common factor first and then finished factoring from there. That is the difference of two squares. Okay? All right. So then perfect square trinomials, how are we factoring them? Okay? So we have x squared minus 8x plus 16. Okay? To see if it's a perfect square trinomial, I look at this first term, and that's just x squared. And then I look at the last term. Can I write that as something squared? And I can. 16 is just 4 squared. Then what I want to do is it's minus here, so I want to check to see if it's 2 times the first times the last. So does negative 8 equal negative 2 times x times 4? And it does. So this is a perfect square trinomial. So I can factor it by the pattern. So it's the first. This is minus, so I subtract the last, and then I square it. Okay? All right, the next one, 9y squared plus 60y plus 100. Okay? Again, can I write this first term as something squared? Well, 9 is just 3 squared, so I can write that as 3y squared. 100 is just 10 squared. Then I'm going to see if this is equal to the product here. So 2 times 3y times 10. Does that equal 60y? So 2 times 3 is 6, times 10 is 60. So it is. So this is a perfect square trinomial. So the first term was 3y. Then it's plus, so I'm going to add the second 10, and I'm going to square the whole thing. So I get 3y plus 10 squared. Okay? Then something like 2x squared minus 12x plus 18. So to see if this is a perfect square trinomial, right, I cannot write 2x squared as a quantity squared. Can't do that with 18 either. 18 is not a whole number squared. But what I notice is these are all even numbers, which means I can divide everything by 2. So I can factor out a 2 first. So then I get what's left is x squared. Negative 12 divided by 2 is negative 6x. And 18 divided by 2 is 9. Okay, then I want to see if this, what's left here, is a perfect square trinomial. So I factored out a 2. Okay, then x squared is just x squared. And 9 is 3 squared. Then check to see it's negative, so is this minus 2 times x times 3. So negative 2 times x times 3 does equal negative 6. So I can factor it to x. This is a negative, so minus the last squared. So I get 2 times x minus 3 quantity squared. Okay? So again, just like every other lesson, this factoring allows us to try to solve a quadratic. Our ultimate goal is always finding x, but you need an equal sign, okay? So once you get the equal sign, then you can solve. So we want to solve negative 3x squared minus 18x minus 27 equals 0. Okay, so notice that they are all divisible by 3. So I'm going to factor out a negative 3 first. So dividing this by negative 3, we get x squared. Negative 18 divided by negative 3 is 6x. And negative 27 divided by 3 is 9. Then I'm going to factor here, okay? So this is a number squared, and 9 is squared, is 3 squared, and 6 is 2 times x times 3. So I factored. Now I solve for x, so I'm going to divide everything by negative 3, and I get x plus 3 quantity squared equals 0. Then you would take the square root, and I get x plus 3 equals 0. And then you're going to subtract 3. And we get x equals positive 3 as our solution. Okay, so once you factor, then you can solve for x like we have before. Don't get to this step where it's x plus 3 squared and then multiply it out. Okay, that'll undo your work of factoring. So factor and then use like the zero product property and you'll get x by itself. So special products, okay, they're shortcuts. If you don't remember them, okay, or you don't see the patterns that we have, these three, you can factor normally and you'll get the same answer.